Hi everyone, my name is Erisa. I'm going to take you through some topics in algebra. And today we are going to talk about quadratic equations. This topic targets students who are taking pure mathematics at advanced level, or students who are taking mathematics in their high school. Okay, so we're going to talk about quadratic equations, but basically the emphasis will be on the roots of quadratic equations. Okay, so the roots. That's what we are going to talk about today. We know that the general quadratic equation can be written as ax squared plus bx plus c equals to 0. Okay, where a, b, c, these are integers called numerical coefficients. Numerical coefficients, and the x, the quantity to be found. So that's how any quadratic equation can be represented. It is ax squared plus bx plus c equals to 0, and the a, b, c are numerical values. Okay, they are just integers. Okay, this is an example of a quadratic equation. Let's look at 2x squared plus 5x minus 12 equals to 0. Here a equals to 2, b is equal to 5, and the c equals negative 12. Okay, you can start these are integers. When you look at another example like x squared minus 7x plus 11 equals to 0. Still, this is a quadratic equation with the a equal to 1, b is equal to minus 7, and the c is equal to 11. Okay, so we are saying that we are emphasizing the roots of quadratic equations. So we must know how do we find the roots of a quadratic equation. So let's talk about solving quadratic equations. Solution of quadratic equations. How do we solve quadratic equations? There are so many methods of solving quadratic equations. One would decide to just graph and come up with the solution. Okay, that's one way. We can solve by completing squares. We can solve by factorization. Okay, we're not going into the details of that, but we want to emphasize one method here of solving quadratic equations, and that's completing squares. But before we go to completing squares in a minute, let's talk about factorization. Okay, consider 2x squared plus 5x minus 12 equals to 0. Okay, so if you had solved this equation by factorization, then we must be able to, if we can find can find two values, not values, but two numbers. Let me erase that so we can have some. If we can find two numbers, okay, whose sum is 5 and the product is 24 negative, okay, then the above quadratic equation can be solved by factorization. So we can solve the above equation by factorization if we can find two numbers whose sum is 5 and the product is negative 24. Okay, so these numbers will come from the product or factors of 24. Okay, but here you can see that a negative 3 and a positive 8 will sum to 5 and then you multiply to 24. Okay, so how do we solve for such an equation with the factors known to us? Okay, so let's talk about this in a minute. So we said these are negative 3 and the 8. So this is how we go about it if you had factorized. Okay, it will mean that over 2x squared, the 5x will be written in terms of the sum of these factors. So we shall have 8x minus 3x, okay, minus 12 equals to 0. And we can start if we group 2 and the 8, then a 3 and the 12, we can have this as 2x into x plus 4. That's a common factor between these two. And here there is also a common factor, which is a minus 3 into x plus 4. This gives us 0. So if you had factorized the quadratic equation, after this step, the two brackets, this bracket and this bracket must look the same. Okay, they must be exactly the same, so they can be factored out, and then you end up with the x plus 4, okay, into 2x minus 3 is equal to 0. So from here you go ahead and find the factors and find the roots, because these are now factors. So if you go ahead and solve, you end up with x is equal to minus 4 and the x is equal to 3 out of 2. By equating each bracket to 0 and trying to make x the subject, you end up with those two values, and therefore these are roots of quadratic equation. Okay, but this is not really our point of focus today. What we are focusing on basically are roots of quadratic equation is, and we want to talk about the method of completing squares. Let's talk about solving quadratic equation is by completing squares. Okay. This is our major focus today. How do we solve quadratic equation is by completing squares. Okay. So let's use two examples here and master the technique of completing squares to solve quadratic equations. Let's consider simple equation. Let's use 8x squared minus 2x minus 3 equals to 0. We want to complete squares and then end up with the x values. The first step in completing squares, take the constant term on the right hand side. So we're going to have 8x squared minus 2x equals to 3. Okay, next step, divide through by the coefficient of x squared, and in this case it is 8. So let's divide through by 8. We have x squared minus 1 over 4 of x is equal to 3 over 8. Okay, what's the next step? The coefficient of x is multiplied by a half. Square the result and add on both sides. So we have x squared minus 1 over 4 of x plus, if I multiply 1 over 4 by 2, I end up with 1 over 8. If I multiply 1 over 4 by a half, I end up with 1 over 8. I'm squaring and adding this on both sides. Okay, 3 over 8 plus 1 over 8 squared. Why do we add it on both sides? The reason is we don't want to change this step. So adding 1 over 8 squared on both sides, this cancels out and it goes back to the above step. So it's not really something, we're just modifying this step. We're not doing anything like adding the constant term on both sides. That term is going to cancel out and it always comes back to that second step. So what comes next here? Okay, what comes next? What you are going to do, don't bother squaring this term on the left hand side. Just write x minus 1 over 8 squared is equal to 3 over 8 plus 1 over 64. Okay, and the x minus 1 over 8 squared. If you go ahead and do the mathematics here, adding fractions, you will end up with 25 out of 64. So how do we find the x values? This is what we do. Let's take the square root. X minus 1 over 8 squared d, take the root. Okay, is the square root of 25 out of 64. So squaring and square root, that cancels out. You have x minus 1 over 8 is equal to a positive or a negative 5 out of 8. Okay, so from here you can get the x values. You're going to get two x values because the square root of a number is either positive or negative. So we can get x minus 1 over 8 equals to 5 over 8, meaning that x is equal to 5 over 8 plus 1 over 8. You get 6 out of 8, and that is 3 over 4. Okay, or x minus 1 over 8 is a negative 5 over 8. Okay, so what does that mean? We have x is 1 over 8 minus 5 over 8. That is 4 over 8, and that's negative a half. Okay, so therefore x equals to 3 over 4, or x is equal to a half. And I've got the two x values. You have solved the quadratic equation by completing squares. Why are we doing this? It looks too elementary, but we are going to discover in a minute. So let's work out one more example about completing squares, and then you go to the general setting of a quadratic equation and see how useful this kind of knowledge I'm talking about. Okay, let's consider the quadratic equation, which is 5x squared plus 10 is equal to 17x. Okay. Of course, this quadratic equation does not appear like the general form we have written down, but we can arrange it and it looks like the other one. So we have, this means that if we have to make it a quadratic equation, quadratic equation must be equal to 0. We have 5x squared minus 17x plus 10 is equal to 0. So it's now a quadratic equation. Okay. How do we go about it? By this method of completing squares, we say take the constant term on the right hand side first, and then after divide through by the coefficient of x squared. Let's do that. Okay, 5x squared minus 17x is negative 10. Okay, divide through by 5, we are going to have x squared minus 17 over 5 of x is negative 2. That's when you divide through by 5. 10 divided by 5 is just negative 2. Okay, so how do we go about this next? We say the next step, which challenges some students, that is the coefficient of x, in this case is negative 17 over 5 multiplied by a half. Okay, what you get, square it and add on both sides. So we have x squared minus 17 out of 5 of x plus 17 over 10 squared, okay, is equal to negative 2 plus 17 over 10 squared. Okay, so what do we get? This is 17 over 10. Now, the left-hand side, don't bother squaring 17 over 10 because this is going to condense to x. It takes this sign here. Don't forget, x minus 17 over 10 squared equals to negative 2. When you square 17, I think you get 289 divided by 100. So go ahead and do your mathematics. Okay, that is minus 200 and the other is 89. You have x minus 17 out of 10 is the same thing as minus 200 plus 289. This is divided by 100. So what do you end up with? Remember, there's a square here. Okay, you get x minus 17 over 10 squared is the same thing as 89 over 100. So we go ahead and take the roots on both sides. You have x minus 17 out of 10. Okay, if you want, you can write this step, but we are taking the square root. It is the same thing as the square root of 89 divided by 100. I don't know, do we have the root of 89? 89 does not look a square number. It's 81, which is a square number. So here we have x minus 17 over 10 is the square root of 89 divided by 10. But the square root of 89 is either a positive or a negative. So we get two x values. One x value is when you decide to take a positive root. So either x is equal to root of 89 over 10 plus 17 out of 10, I think when you solve here, you're going to have 17 plus root 89 divided by 10. That's one x value. Or the other x value is x minus 17 out of 10 is negative root of 89 divided by 10. And you have your x as 17 minus root 89 over 10. So we have two x values. The first x value is 17 plus. The second x value is 17 minus root of 89 over 10. So we have solved the quadratic equation by completing squares, okay? But how is this relevant to what we want to discuss today? Let's get the general format of a quadratic equation and see how this knowledge is useful, and then how is it going to help us in looking at roots of quadratic equations. So with the knowledge of completing squares at the back of our minds, let's talk about the general format of a quadratic equation, which is ax squared plus bx plus c equals to 0. So let's complete squares. Completing squares, okay, gives, you have, we said the first step in completing squares is take the constant term on right hand side. You have ax squared plus bx is equal to negative c. So next step, divide everywhere through by a, and you have divide by a by a divided by a. You end up with x squared plus b over a of x is equal to minus c over a. So what's the next step? We say this coefficient of x, okay, you half it and then square the result, add on both sides. What do we end up with? Okay, we shall have x squared plus b over a of x, then add b over 2a. Remember, b over a is the coefficient of x, but we multiply it by half. So we multiply by a half, you get b over 2a. We square and add on both sides. Equal to c over a plus b over 2a squared. Okay, so we said the left hand side, always don't bother squaring. It is always going to be x plus, okay, this side is preserved, so it is plus b over 2a, this is squared, will be negative c over a, then plus, let's square the other side, we have b squared over 4a squared. So what's the next step? Okay, let's go ahead and combine the two fractions on the right hand side and this is what we get. You have x plus b over 2a squared is equal to, here the LCM, you can see that the LCM of these two is 4a squared. So what we do, we get our LCM, which is 4a squared. Now 4a divided by a, you get 4a squared divided by a, you get 4a. So this minus 4ac, okay, plus this is going to be b squared. Okay, so look at this step so critically. This step is so important in our discussion today, ladies and gentlemen. This is very important. Let's go ahead and simplify it. What do we get? Okay, what do we get when we simplify this? We have x okay, plus b over 2a. This squared is the same thing as b squared minus 4ac divided by 4a squared. Let's take the square root on both sides. We have x minus b over 2a. This is squared. Okay, we are taking the root on both sides is equal to the square root of b squared minus 4ac divided by 4a squared. Okay, when you look at the right hand side, the numerator is not a perfect square, but the denominator is a perfect square. So we can write this as x minus b over 2a is equal to, when you take a square root of a number, it is either positive or negative, of b squared minus 4ac. Divide this by 2a, because 4a squared is a perfect square and its root is 2a. So if you make x the subject, okay, this will be a b over 2a plus or minus the square root of b squared minus 4ac. This is over 2a, okay? And if we go ahead and combine fractions, we get x is equal to minus b plus or minus the square root of b squared minus 4ac. Divide this by 2a, okay? And this is the major focus of our discussion today. This is what we have been aiming at, and this is what we call the general quadratic formula, or the formula for solving any quadratic equations. Okay, let's see how we use it. So this formula, if we substitute the coefficients of any quadratic equation, it will always produce two x values. One x value, let me call it alpha, okay, is equal to minus b plus the square root of b squared minus 4ac divided by 2a. That's when we take a positive root, okay, of this part. Now the other value, I will call it a beta. Beta is equal to minus b minus b minus the square root of b squared minus 4c divided by 2a. Okay, now suppose we want to investigate something. We are saying one root is alpha is equal to this part, okay, and then the other root is beta is equal to this. Those are two roots. They only differ by the negative sign. This is minus, this is a plus. What if, okay, we try to add sum of roots? Sum of roots. Okay, I get alpha and I add to beta. This is going to be minus b plus the square root of b squared minus 4ac divided by 2a, and I will add on another minus b, okay, then minus square root of b squared minus 4ac divided by 2a, and you discover that alpha plus beta, which is the sum of roots, is going to be, since the LCM are the same, we can go ahead and add. We have minus b, okay, plus the square root of b squared minus 4ac, and we are having another minus b minus the square root of b squared minus 4ac, divide this by 2a. So what is that? This will cancel out. And what do we get? Alpha plus beta is giving us minus 2b over 2a. Okay, so what do we get? Just simplify, a 2 cancels out and you end up with. So we are having now sum of roots, okay, and that is alpha plus beta is equal to minus b over a. Okay, so it is a very important result that we shall need to highlight. Okay, sum of roots alpha plus beta is a minus b over a. So if the sum has given us this result, what about the product of roots? What about the product alpha beta of roots? Okay, if I take the product, what do I end up with? Okay, remember we had alpha. Okay, alpha was equal to minus b plus the square root of b squared minus 4ac divided by 2a. And now we want to multiply this by minus b minus the square root of b squared minus 4ac divided by 2a. Okay, that's the product of roots. Now, the denominators are the same, and the numerators are also the same, except that one is a conjugate of the other, or here we have a minus sign. Okay, so what do we do? How do we go about it? Okay, let me first rub this so I don't spoil my results. This is a minus b minus. Okay, so how do we go about this? Let's multiply through. You have been multiplying through some of these brackets, distributing brackets, and there's what we call a difference of two squares. Okay, if you have something like this, a minus b, okay, into a plus b, you end up with the a squared minus b squared. Now, we want to make use of that result, a minus b into a plus b, which gives us a squared minus b squared, and we write that alpha times beta is going to be minus b squared minus the square root of b squared minus 4ac, this is squared, all over 4a squared. Okay, that is what we call a product, or a difference of two squares. It's going to give us b squared minus, okay, in the bracket b squared minus 4ac all over 4a squared, which will simply be 4ac all over 4a squared. Remember, this is our alpha beta, the product of roots. Okay, so alpha times beta, you end up with 4ac, and this is the same thing as just c divided by a. Okay, so let's write this small result here, because we're trying to economize space. We are having alpha beta is equal to c over a, and this is very important for us, ladies and gentlemen. Okay, remember our sum here is alpha plus beta is minus b over a, and now the product is giving us alpha beta is equal to C over A. Now, these two results are important when we are dealing with the quadratic equations. Let's see how they're important. So, ladies and gentlemen, we now have two relations about the roots of quadratic equations. Okay, we have sum, which is alpha plus beta as minus B over A, and the product alpha beta is just C over A. So how do we make use of these two results? Okay, sum is minus B over A, and the product is C over A. Let's look at this example. Okay. There is an example we should look at and see how we exploit these two relations and then solve problems on a quadratic equations. Okay. So in this example, they're telling us to find the relation between A, B, and C if one root of the equation x squared plus bx plus c equals to 0 is 3 times the other. Okay, let's have a solution. Okay, let the roots be alpha, so the other will automatically be 3 alpha. Okay, so sum, we have alpha plus 3 alpha, which is equal to 4 alpha which is 4 alpha is going to be minus B over A. Then we have the product, which is alpha and 3 alpha. This will be 3 alpha squared is a C over A. Now they want a relation between A, B, and C. So in this case, what we struggle is to eliminate alpha. If this is my equation 1 and this is my equation 2, okay, I can see that 1, if I square 1, I will have 16 alpha squared is equal to a b squared over a squared. Okay, why am I struggling? Because I'm going to eliminate alpha. Okay, now what I do, I'll have 16 alpha squared. If I divide by 3 alpha squared, I'll end up with b squared over a squared. Divide this by c over a. And I think if you go ahead and simplify, this is going to be b squared over a squared, okay, times a over c, okay, yeah, times a over c. And therefore, what do you get? You end up with the b squared over a c. So let's go ahead and write the relation. Okay, remember on the left hand side, this goes in the process. So we have 16 over 3 is b squared over ac. If you go ahead and cross multiply, you have 3b squared is equal to 9 is equal to 16 ac. And that's the relation they are talking about. This is the relation between a, b, and c. If one root of that equation is thrice the other. Okay, let's look at example 2. Example 2. Remember, we are trying to solve some small questions about roots of quadratic equations. It is elementary algebra for beginners. You know, when you are starting to warm up, you want to take serious mathematics. These are the things that we want to be at your fingertips. That's why I'm giving you this simple lecture.